You need to start mapping right now. You might be wondering, what even is mapping? Basically, it's validating if a hotspot is really located at the specific position it shows in the network overview. If you ever operated a Helium hotspot, your own, or used the Helium Explorer, you know that hotspots need a location. For the network, it's important that we validate these locations so that the operators and the users have the availability of the LoRaWAN network of Helium at their specific position. Let's say a Helium hotspot, an access point, however you want to call it, is providing coverage to a certain position, and you as a user want to use the network at this area. How can you safely say that there is the network available? By proving the locations. So today I will show you what a mapper is and how you can install and operate it your own. So let's get started. How does a Helium mapper even work? So let's say we have a Helium hotspot with an antenna somewhere around in the area, and maybe it is on a tower or something like this. And we have a city over here with some houses, and they want to get into the Helium network with some antennas on their roofs. So this Helium hotspot is sending out data, and these antennas, these LoRaWAN antennas, receive those signals. But if you are unsure if you get a Helium access in your area, you can use a mapper and try to prove or to validate if there's even access to the network. So let's draw a GPS satellite really quick. So this should look like a GPS satellite with a little antenna, and it is sending GPS signals, yes? And we have our mapper. This mapper has an antenna for LoRaWAN, for the network of Helium, and we have a little GPS antenna that is receiving GPS signals from the GPS satellite. So by using this device, we can stand in a specific area or at a specific location. We can use our GPS signal to validate on or in which area we are currently located at. If we get a signal of one of the Helium hotspots, let's say this one is number 1, and we get a signal from them, so they are sending back some data. We have proven that in this area is access to the Helium network, and this data will be sent out over the Helium network into some servers. Let's say this is an AWS server. There's some Helium software running behind Helium, and this hotspot is sending the data into the AWS server that is currently operating the Helium software, and this data is then written to a map of our world where we can see the Helium mapper at a specific location. So I will show you the map in the next step. I loaded up the Helium Mapper Map, and I need to scroll out a little bit so that we can see the whole world. So this is the whole world. And if I go over to Germany, let's say we're going to Munich, kinda looks familiar to the Explorer of Helium. But it is different, it is for mappers specific. So those gray hexagons, those are the hexagons where some miners or hotspots or Helium access point, however you want to call them, are located in. And those smaller green ones, those are GPS information from Helium Mappers. So let's say someone is driving on this road with a Helium mapper, and I click on one of them, and now you can see something interesting. You can see that this position and the mapper on this specific position mapped 3 other hotspots and has proven that those hotspots are really located over there. So we can improve our network by doing this, and we can create sustainability for the network, because now new businesses and other use cases can come up and can create around the Helium network, because people in Munich know, if I set up some LoRaWAN devices at this specific position, I will be sure that I get a connection to the Helium network. So we are proving that those hotspots are really there, And sure, 3 is maybe not enough. We can click something in the middle here. Let's see, 2 over there. So you can click around a little bit. There's another one, that's good. So you only need to go to the website mappers.helium.com, and then you can scroll to whatever position you would love to see if there are really hotspots located. Then you can take your device, go out there and map. So, and someone at this specific location, so this hexagon is a little bit smaller than the hotspot hexagons. Someone stand somewhere in this area and he was getting a lot of connections. So he got 74 different hotspots. It's a good redundancy. We can even see how good those signals are. So we can see the radio signal strength indicator, we can see the signal noise ratio, and we can see the estimated distance to other hotspots, or to the hotspots that were mapped. So I ordered myself a device, and this device is called TTGO T-Beam. I will put down a Amazon link in the video description down below. Basically, this is the Helium Mapper I talked about. This device comes with a couple of connectors. If you are into IoT stuff, you can do a couple of things with this device. You can connect some stuff over there, but basically that's it. On the bottom you can put in 18650 battery. On the bottom we have a micro USB connector, we have the power button, we have another use case button, and we have the reset button. On the left side we can see the connector of our GPS antenna, and this is our GPS antenna. I ordered another one that is a little bit bigger than this, because this little GPS antenna takes some time to connect to the next satellite. Normally it's fine, and you can do this. And on top you can connect the LoRa antenna. So you just screw this on, and basically this is the device. The next thing we need to do is to connect via micro USB our TTGO T-Beam to our computer, and we will go on the computer with the next step. So the next step we need to do is to download Visual Studio Code, and you can do this by clicking on download for Windows, or choose another version, whatever you're using, downloading this, installing this to your device. And if you have done so, we can go into our Visual Studio Code. Don't be scared, this normally looks a little bit different, but if you open it the first time, you will see something like a README file or something else. But in this case, we need to install an add-on, and the add-on is called Platform IO IDE. So what we are doing is we are typing in on top in the search bar. Let me get this down a little bit. So we click on the application button on the left side, and after this we can search for application, and this is called Platform IO. And if you have done so, click on it and click on install. Currently it is installed for me, so I don't need to install it again, but basically this is all you need to do. The next step we need to do is downloading our software for the TTGO. So the next step, as I mentioned, is to download the software that we need for our TTGO, and this we can find on the GitHub of Max Plastics. Basically, yeah, this is a repository, and he's explaining some steps what you can do with this device, what kind of supported hardware is this with his software. But what we are doing is we are clicking on code, and we are downloading this as a zip file. If you have done so, and I will quickly go to my downloads directory, we can see that I have downloaded this file and I extracted this to my downloads folder. So perfectly. We can go back to Visual Studio Code, we can click on Files, Open Folder, and by directing to our downloads folder, I can click on T-Beam Helium Mapper -main. Open this folder, and then we can go back to our files. Normally you should now open the platform io.ini file. If you do not, don't worry, just click on the Explorer file on the top left and then click on platform io.ini. This will open the file we need now. So now is an important step. If you are living in the US, you don't really need to change anything. But if you're living in Europe like I do, your code will probably look something like this if you download this file or this folder the first time. So what we need to do now is to eliminate or to delete this semicolon and to get this D over there. So we are activating the frequency 868. And now we need to add a semicolon to the US version, and I like to press once the space. It's just for good looking stuff. You don't really need to do this, but just keep the semicolon there that this frequency is not added. And now I will connect my TTGO T-Beam. Okay, and now what we can do is we can click on this little alien button, the platform IO button, and we can first click on clean all. So it will clean everything. Perfect. And the next step we need to do is to click on upload and monitor all. So I will do this. This will basically now compile all the things we have done in this script or in these files, and it will start uploading the new serial codes to this device. So it will update the firmware, and at the end it will give you some numbers that we will need to paste in our Helium console that we can activate our mapper. Okay, perfect. I will try to blur my numbers over there, and I will show you how we can go ahead with this. So let's scroll up a little bit that we can find the def EUI MSB, the app EUI, and the app key. Those three numbers over there that I will probably have blurred out at the moment, those are the numbers that you will need for your Helium console. So get those numbers, copy them somewhere, and we will see us in the Helium console. So we are now in the Helium console, and now, or before you can do anything, you need to create an account over there. I already have done so, so I'm currently logged in. At the top right corner, if you create the first time your account, you will get a free credit of 10,000 data credits for the Helium network, so you can start mapping for quite a while. What you need to do now is go over to devices, and we need to add a new device. We're doing this by clicking on add new device. If you do so, give your mapper a unique name. Let's say, for example, once mapper, whatever. So, and now we have the def EUI, the app EUI, and the app key. Those numbers we have found in the Visual Studio Code in the terminal I told you to copy. Those are the numbers we now need to copy over there. So we are grabbing the first one, the def EUI MSB, and we are copying them into the def EUI. After this, you do the same with the app EUI, and last but not least, the app key. You can now click in profile if you want to do so, or you can create one, and you can even attach a label to it. After this, you can click on save device. I already set this device up, so I don't need to do this. The next thing we need to do is to create a function. So we need to decode the stuff that the Helium console knows what to do with the data it receives. So basically, you click on add new function. After you've done so, you can name it like a decoder or whatever you want to do, and you can give it a type. We say it's a decoder. We chose a format. We say it's a custom script. And Now we need to paste some stuff in here. So you can delete everything that is in here. You can go back to the GitHub repository of Max Plastics and you can click on console decoders. On this, you click on unified decoders.js and you copy everything that is in here and paste it in. Just paste it like this. After this, you can save the function. So we are done with the decoder. Okay, the next thing we need to do is we need to create an integration. For this, you can do two different types. We can either send all our data to the mappers.helium.com website and see those little green hexagons over there. Or we can say, okay, we are doing double the data like I do, because I present my data to the Helium Mappers and I present my data to the coverage map. This is a different map, but I will show you how to do this in a second. So for the next part, we need to do an integration for our Mappers map. For this, we create a new integration. So click on integration and then click on HTTP. And now we need to go to the Mappers API or the docshelium.com website and just copy this line here. I will probably post this in the video description down below, so you don't need to open this website extra. Enter the key over here. Now take this uplink, paste it in here and give this a name. I will name this video test or whatever, and then you can add this integration. If you have done so, the next thing we need to do is to go over to our flows. So what we are doing here, let's see, we need to create flows. So what you want to do is you click on devices, then you click on your mapper, and this will add your mapper. The next thing you need to do is you need to add your function. So click on function, then on your decoder. And the last thing you need to do is click on your mappers. I named it test video, as you know, like a second ago. And this will add the integration here as well. After you've done so, you can just click on those little circles here and you can draw lines. So left click on it and hold it and go to the next line. So you go from your mapper, from your device to the decoder and then into your integrations. Either it is mappers for the Helium Mappers website, this one here, or it will be for the coverage map, but I will not mention this in this video because for most of you guys, it's okay if you only present the data on the Mappers website, and this is absolutely fine. After you have done so, there's a last step you need to mention, and this is the multiple package. What you can do here is you can create your own multi-package configuration. For this, you only click on add new multiple package configuration. Then you can drag this circle and add the number you like. What this does is really simple. It will allow, in my case, I set it up to 3. It allows my mapper to connect up to 3 hotspots and track them. I can do more, I can do less, or I can do all available. What this will does, it will send the data to all the Helium hotspots that are in your next area, and if they receive this and send it to the Mappers website, you will pay per package 10 data credits. So if you do this not so often. I would say if you're running around in the city and you are trying to just map the city, set it up to 3, and then you are good to go. It's absolutely fine. You don't need to do more. So the last step, or there is no more step, but the last thing I want to mention is you can click on devices. You set up your device earlier before. You can click on it, and if you scroll down, you will see your flows, and you will see some sort of real-time packets. And this is absolutely amazing. If you set up your TTGO Helium hotspot and it got a GPS connection and it joined the Helium network, you can see the live data of how many hotspots you reached, what the time, and what type of connection you got. And this presents you the data that you are live with your Helium Mapper, and then you can go on the map, scroll to your specific location. Let's say again, Munich. You're running around Munich, and let's say you're somewhere in the southeast and you're standing somewhere around here. Then you can see your new green hexagons appearing here, and you can click on your hexagon and see how many hotspots you you achieved from your certain position. So guys, I printed myself a case for my TTGO T-Beam. It's a little bit different because I have another GPS antenna inside here. I added a battery into it so we can just power it up. There we go, Max P Mapper. So I go outside and we can see in the moment that we are getting connection to the GPS satellite. So give it a couple of seconds. You could need a little bit of time. On the top it's currently saying that we have no GPS. There you can see you can also see the time, and you can see the draw of battery. So now it is connected with 4 satellites, and I can press the second button and we are sending, and this data we can see live in our Helium Console. And there we go, we can see the live data that it has been sent a couple of seconds ago. I could now go to the mappers.helium.com website and show you that I mapped something, but I mean, you know how this works. Thank you guys for watching, and see you on the next one.